Good morning, ladies and gentlemen. So I'll talk from here and take questions from there for some variety. So I was here yesterday briefly, and I promised to talk in more detail than I did yesterday about about the future of technology, the new technology. Before I do that, though, I'll look back a bit at about the past, what it was like trying to actually get people to use the web all those years ago, more than 20 years ago, when people didn't understand what it was to click. They didn't have the same vocabulary of understanding about web pages and clicking. They didn't understand about being able to get at any information in the world. So, I suppose going back, as I mentioned yesterday, my parents were both mathematicians, and so when I was little, my world was full of mathematics. My mother at one point was teaching children, and she needed to explain to them why mathematics was important, so she always tried to find opportunities to point out when something was mathematical. When you was baking a cake, or the way you had a recipe for a round tin, and you needed to work out how much to put in a square tin, then suddenly you discover pi and the likes of that just from baking a cake, and so on. They were both excited about mathematics, and they were involved in building the very first computers. The first computers were big machines. There were only a few of them, and when they were driven with paper tape, which this reels of things that they had just 5 holes across. When I was little, my parents would bring them back from work, these programs that they'd written on big pieces of reels of paper tape, and it was great when you were little to just throw them around at each other and cover the house with reels of paper tape. So computing was fun. What they found was exciting was that when you programmed a computer, because of the law, the Turing's theorem, or that basically if you have any one computer, once it's a computer, it can emulate any other computer. Therefore, the set of things that computers can do are all the same. So all computers are in a way equally powerful. Some will be fast, some will be slow, but once you have a computer, which is a Turing machine, then you can do anything which you can imagine. By the way, it's interesting to know who I'm talking to. So I'd like to take some polls. So hold your hand up. First of all, languages you speak. So who here speaks Arabic? Thank you. Quite a lot. Who here speaks English? A lot. 2. Who here speaks Python?
What?
JavaScript? Yes. Okay, we have some programmers. Great. And who here has programmed in any computer language? All right. Thank you. So, well, I will try to be able to try to talk to you whether you've used a computer language or not. But those of you who have understand how exciting it is, and my parents understood that. I grew up with that excitement. I actually studied physics. I enjoyed building electronics. I enjoyed mathematics at school. I ended up studying physics at university. It wasn't really, I thought it would be sort of halfway between the two. It wasn't really, it was its own thing. But I think one of the things I did learn from physics was generalization. When physics, you look at it, and you drop an apple once, and then you drop a tomato, and then they both fall to the floor, and you think, maybe there is a general rule. How can we generalize that? What is there that's in common? How can we make this law, how can we make this science simpler? by generalizing it, making it simpler so that it applies to more things. That, I think, is an important part of the design of the web, is it being it's a universal space. So, when I was a kid, then I was excited by electronics. When I was growing up in high school, we could build things with integrated circuits. And in principle, I understood, by the time I got to university level, I understood in principle how to make a computer. And my friends and I were the sorts of people who would have sat down and built a computer. As we got to the stage there where we were building things not with single transistors anymore, the integrated circuits had come out, and we knew in principle how to build a computer. But what was amazing for me, just as I came out of university, 1976, Motorola introduced a computer on a chip, 2 inches long, 40 pins, the entire processor, the 6800 processor. So I bought one of those. So suddenly, whereas I felt very lucky to be in the generation that had built things out of transistors, and we built things out of little integrated circuits. Suddenly at that point, that magic point in 1976, you could get a microprocessor. And suddenly, instead of building lots of electronics to solve the problem, you could just connect all the wires up to this processor and then solve the problem in software. So I was one of the few people who was really excited about that at that point. I left university, I did not do a PhD, I still don't have a PhD. I have lots of honorary degrees, but no PhD. And I went into industry, and I was one of a number of people who did things with microprocessors. So that's where I was coming from, and I was a software engineer. Maybe it was interest in physics, which took me to CERN. Maybe excuse me, let me just set myself up a timer. Oh, I'm getting a new microphone. Is that better? Try that out. Is that okay? Or use this one? Okay. All right. So there I was an English programmer, worked with a number of small companies, and then I had the opportunity to go to work at CERN. CERN, the European Particle Physics Lab. Okay. The particle physics lab at CERN was a wonderful place, full of people trying to build really complicated big machines. If you could visit CERN, then do. When you go there, you go down a tunnel deep in the ground and you find huge pieces of electronics put together by people from all over the world. And what I found there was this great exciting environment, but also a lot of diversity from the people, because people had come from all over the world. But as they came from all over the world, they brought computers from all over the world, and they programmed those computers in different languages. And if I had a poll then in the group of people at CERN, I could have gone on asking them different programming languages that they'd use, and some of them had invented their own programming languages. CERN was a very inventive place, full of physicists who were very creative people. And in fact, they had to be careful. They didn't just rewrite every program they came across, a new word processor, and so on. So there was this tremendous diversity, and if you arrived there as an engineer, and you had to work and build a piece of it, then it was difficult to figure out how all these pieces connected together. When I was first at CERN, I just had in 1980, I was there for 6 months, and I wrote a little program called Enquire, which was designed to be able to track. It allowed you to take notes, but it allowed you to make links between any two nodes in an arbitrary graph. You could make a link between any note and any other note. That was a system called Inquire, and it was the basis, I suppose, mentally for the World Wide Web later. The World Wide Web was in 1989. I felt that the situation was, if anything, worse. There were all these computers were sitting there with interesting documents on them. Different computers, different operating systems, different documentation systems, and different formats for the way the document was stored on the disk. And there was an internet. The internet was connecting up to these computers. The internet had just come. It has spread across mainly America, just come to CERN. So these computers were connected up. They had network connections in the back. So in principle, you should, if you're sitting on one computer, be able to get at the information on another computer. But it was impossible because there were no standards. It was impossible because all the documentation systems were different. And that was very frustrating. That if you, even though in principle you could do that, that in practice you couldn't. So that was a challenge to a programmer. Remember that if you can imagine it, then it's just a question of programming. Okay, so for me, I started to try to persuade people that we should build this imaginary system. We should build a virtual documentation system, it was a virtual system which would exist on the internet and would include every document in every documentation system that we had. And I looked at it and I realized that if you took the ideas of hypertext, actually every documentation system could be made, it could be mapped into the world of hypertext. It could be converted into the world of hypertext. So I tried to persuade people that it would be a good thing to work on. But it was hard because CERN had so many people jumping up and down and saying, I want to program this program. I want to write a new operating system. I want to write a new network system. That they had to be careful, and they very naturally said, well, Tim, we should surely, if that is a good thing to have, we should be able to buy it. Let's wait until the IT industry produces it. However, my boss, Mike Sandel, who's unfortunately since has died, so he's no longer with us, but at the time, he realized that I was excited about buying a Next machine. Next, hold up your hand if you remember the Next machine. Not very many. Let me tell you, younger ones, that Steve Jobs, who you probably do know of, at one point left Apple. He just argued with Apple. He set up another company to build a machine called Next. He set it up as an alternative to Apple. And it was a brilliant machine. It was a Unix machine. It was black. It was mean. It had digital signal processors in it. It had optical disks before its time. And it had a program that allowed you to make programs. It had an interface builder. So it was designed to be really good for developing programs. So Mike Sandel, my boss, he said, hey Tim, you've been interested about getting the Next, I know. Why don't we get to it? And why don't you try it out? And to try it out is supposed to be really good for developers. So to try it out, you need to develop a program. So why don't you just find some play program, something that you could develop just to test out the system. Okay, like how about that hypertext thing you've been talking about? So with a wink in his eye, Mike, I never got the official go-ahead, yes, Tim, you should develop the World Wide Web. We will give you some budget and we will give you some time. It's just, why don't you test out the system and see what you can build on it? So he said yes to that in September of 1990. I got the Next out of the box, started coding. Then it took about 2 months. In fact, at that time, we were expecting our first baby, the 24th of December. And CERN closes, at that point it closed over Christmas, so I'd have a period of time when I couldn't work on it, and anyway, there were much more exciting things happened. So I basically worked on it for 2 months, and had it more or less working. Had the first World Wide Web browser. Actually, it was a browser and an editor, so it was a read-write thing, running on an Next machine by Christmas 1980. Now Mike died about 10 years later. But when people went through his things, they found a copy of a memo that I'd written about the World Wide Web. And in the corner, in his handwriting in pencil, he'd written, vague but exciting. So I'm glad that he thought it was vague, but when he thought my idea was vague but exciting, I'm glad that the exciting part of it took more decided his later actions than the vague piece. Who knows, if he'd have written exciting but vague, then he'd have never let me go and build the thing. So that is the story of, if you like, it's the story of innovation. It was the story of being allowed, being given some space. And it's a story, a lot of people ask, when did you have that idea? When was a moment when suddenly you realized about HTTP and URLs and HTML, and it all came to you? And they want me to say that it happened in a flash as I was hiking in the Swiss mountains or something. But in fact, so the story you'll see is about a life of working with documentation systems, working on communication systems and learning about other protocols, and being very familiar with lots of different operating systems, a life of writing systems to convert from one format to another, and then realizing and the ability as a physicist to generalize. So many, many things coming together and being given time to, to work on it. From that point, if you like, so then the World Wide Web existed, but it was very small. And it was very hard to get people to understand what it would be like. Nobody could understand it. And now, it's very hard, the most difficult thing for me to explain now is how difficult it was to explain then. Because now everybody understands about clicks, they understand about web pages. But back then, if you showed them, say, look, here's a page, and I click, and then bing, here's another page, they say, big deal. Okay, so what's special? Because they couldn't imagine, they see these two pages on one machine, they could not imagine what it would be like if that link could go anywhere in the world. And now, I find, to a certain extent, the same difficulty explaining things like the web of data to people. So, similarly, I find difficulty to imagining scaling to being very, very large. So, the thing started to grow when I looked at the logs, number of hits on the first web server. There were 10 per day when it started. A year later, there were 100 per day. A year later, there were 1,000 per day. And a year later, there were 10,000 per day. So that is growth. That is exponential growth by every definition. The growth, and that was just the load, that's just the load on the first web server, was doubling every 4 months. So, in fact, it was very exponential. When you put it on logarithmic paper, it was a very straight line. So there's something, a really serious explosion happening. When that exponential growth, we realized that this was going to go on and become something quite big. But we always imagined that there was likely that it could just crash, could just stop. Because yes, we have this exponential growth, but how many things have you seen which go up like this and then go plump? Like go up like this, like the gopher system where it went up like this and then they said it might be not royalty free. All these systems have this, but the World Wide Web was going up like this. Actually, it was going up slower than gopher, but it went on and it went on and it went on. And all the people who were excited about it, every time they got out of bed in the morning, they thought, what do we have to do today to make it work? Do we have to teach somebody about it? Do we have to write some code? Do we have to translate a program into another language so that somebody can use it from another culture? Do we have to work to put some more data on the web? Do we have to persuade more people to install web browsers on their computers? And we were working on all of those things during this explosion. It's a little bit like, I imagine, a bobsled. I've never pushed a bobsled, but I've watched it on TV. And it seems to me that when people are pushing you see the bobsled team, that first, there they have the bobsled and it's stationary and the bobsled team has to push it. And they push as hard as they can. It takes a lot of energy to try to get it going. And there is a certain point as the bobsled picks up speed and it starts to go downhill that they really have to change mode. They have to change from pushing mode to steering mode. They have to get in and steer. Otherwise, there is a disaster. And the World Wide Web was a bit like that. We were pushing it and pushing it and pushing it, and then we realized, whoa, this is starting to move. We need to get in and steer. And getting in and steering at that point meant getting the companies who are getting excited about it together in a consortium, the World Wide Web Consortium. That started in 1994. It's still running at w3.org. You can go to w3.org. It's open. It tries to be fast in the way it develops technology, which is difficult when you have a lot of people who are excited about it and want to be involved. It tries to be fair, so that if you're two companies developing products, like you're two companies developing competing browsers, try to make sure that it's fair, you compare, that we don't develop technology which deliberately makes it easier for one company. We try to be good. We try to make good code. We try to make a powerful system so that the web becomes more powerful. And that's been very exciting. That explosion of and the rush downhill of the bobsled it continues. And if you go to w3.org, you'll see lots of things, some of which I'll talk about. One of the things which was really important early on was that I didn't ask fees for it. There was no royalty payments. It took 18 months to persuade CERN that they would not ask for fees. I realized that I was going to ask everybody to give a URL to their document. That's a big demand. Whatever system you have that you store your documents of, I'm going to want you to give them a URL. Each document must have a thing that starts http:// some name of some computer / whatever you like. You can put whatever you like there, but you must give them a URL. And when somebody looks up that URL, then you must provide them with an answer in something like the HTML standard. And asking that from so many people was really important, because the important thing about a hypertext link is it can go anywhere. So that means that anything can be on the web. And to ask people to put for anything to be put on the web, you can't also say, and there will be a tax. And you have to pay me money. Because then that would have fragmented the system. Other people would have set up competing systems. They would not have connected. So it was a really important part of it, was that I did not ask for payments for people putting things up. So now I'll talk a bit, I promised to talk about some of the new technology. If you go to w3.org, I'm going to talk about two things. I'm going to talk about the open web platform of HTML5, and I'm going to talk about open linked data and linked data in general. So first let me talk about HTML5. So HTML is known as a markup language, the hypertext markup language. Markup language means it's the language that's sent across the internet when a web page is sent from one place to the other. And it's got things, information in it, like this should be a heading and this should be a link. And it's got information about where the link should go to. So designing HTML was one of the easy things, important things at the beginning in the design of the web. And when I originally designed HTML, the language definition would fit on one page. There were maybe 8 different types of tags. There were heading tags and anchor tags, paragraph tags, and that's it. But now HTML5 has a lot of tags. The HTML5 standard is much more powerful. And obviously that means that when you're building a web page, you have lots more things you can do. You can put videos in there, for example. So if the people that you're using your website have got HTML5 compatible browsers, then for those people, you can give them very easily give them a great experience with putting online videos in. You can put scalable vector graphics in, you can move things around, you can put video inside a circle, you can turn the video around and scale it, you can do all kinds of animations. So it's a very, very powerful language, along with CSS, the style sheet language. So that's very powerful, but in a way, the big thing about HTML5 isn't that it's the markup language, it's that it's a computing platform, that it's a programming platform. When I asked, a lot of people put their hands up to say that they speak JavaScript. JavaScript is the language which runs a program inside a web page. When you go to a web page, and it doesn't just sit there, it does all kinds of cool things. When things pop out and you can drill down inside and look at the details of the information. When it does that very interactively, then that's done because somebody has written a JavaScript program which runs inside the web page. And that makes a difference in a way in the web, because the web is originally, I designed it, was a web of documents. And it was sort of static. Yeah, it changed all the time. But each document, the links between the documents, each document, it wouldn't change very rapidly. Maybe a new version would come out tomorrow. But the documents were pieces of information. Now these documents are becoming programs. So the web is becoming a whole lot of programs that can, to an increasing extent, talk to each other. So now that's a very different sort of system. It's very, in the future, the way we allow these web pages to talk to each other, we're allowing them to do more and more things. This will give a lot of power and allow us to build all kinds of really exciting things. Bit by bit, the things you can do on a web page are becoming the things you can do just writing any program. Like a program for a portable device, it knows on a program that runs on a phone typically can ask where it is, where am I, and it can specialize the information it gives you. If you ask for where is a restaurant that says Chinese food, it will tell you a local one because it knows where you are. It gets the location information. A web app, you can write a web app as well, which will do that. That's been around for a while now. Increasing now in the future, what will happen is that also, if you're running a web app on the phone, and you shake the phone, the web app will be able to be aware of whether it's the right way up or upside down, because the accelerometers, the things on the phone which measure the way as you move the phone, will be able to be read by the web app. So the web app will be able to you'll be able to communicate with it with gestures. You'll be able to do all kinds of cool things with virtual reality, augmented reality, holding the phone up to be able to see virtual things about your local environment. So the idea is now that in WCC, in the consortium, that the language is being extended so that anything that you can do on a native phone app, you can do on a web app. And in fact, it's interesting to compare those two things. When you're wondering, should I write an app for the phone, or should I write a web app? Notice that there's a problem. There was a good article in Wired magazine a while ago which pointed out that it said the web is dying because of phone apps. And what it meant was that when you put information in a phone app, it may be very cute, and it may use the user interface of the phone very nicely, and it may react when you move the phone around, but that information is not on the web. It doesn't have URI. If you find something really exciting when you're browsing a magazine on an app on the phone, you can't tweet the URL. You can't tweet it. You can't say you like it. If you don't say you like it, I can't say I don't like it. This information is not part of the discourse of humanity. When you give something a URL, you give it one of these names of http://, then you're making it part of the discourse. You're making it part of the big discussion that humanity is having about itself. You allow people to criticize it, you allow people to be excited about it. You allow yourself to get advertising revenue because lots of people point to such a great page and you get masses of traffic, and when you get lots of traffic, it builds up your advertising revenue. So it's a good thing to do from that point of view. But it's a good thing to do in general because the web is poorer if you don't put it in a web app. you're depriving the rest of the web of the ability to link to it. So if you're a developer and somebody asks you to write an app for a phone or a tablet, then first of all, see whether you can do it in a web app. Maybe like the Financial Times. If you go to ft.com, you'll find they have a mobile app, but it's not something you download on the phone. In fact, all you need to do is you bookmark the Financial Times mobile app. It's a web app. You bookmark it every time, and when somebody clicks on it, it fires up in the web browser. But it saves, it loads down all the paper, today's paper, stores it on your phone, so that if you're offline, you can still use it. So web apps are very powerful. They can do a lot of the things that phone apps could do, and I'd encourage you to do them. To make it easier, there's just a few weeks ago we launched the webplatform.org. Is a site where you can go, which will give you lots of, as a developer, webplatform.org is lots of people putting together all the documentation they could find about all the languages, all the APIs, all the things you need to know as a developer. So go to webplatform.org, it's a wiki as well. So if you go there and you find that the documentation is wrong or incomplete, then please do join and fix. Help everybody else by fixing it. That's webplatform.org, and it's a collaboration of data from many companies and many individuals. So I think that's very exciting, and I think just as the internet, I found an exciting platform to build on when I built the web. I used TCP/IP, and I built on top of it URIs, HTMLs, and HTTP. Now other people use HTML, HTTP, and they build on top of it all kinds of exciting things. And with the Open Web Platform, you'll find that will become even more. There'll be even more creativity, even more innovation, even more new companies starting because of all the exciting things you could do. So that is the web platform, the Open Web Platform. And now I'll tell you a bit about linked data, because the web of linked data is also something which is exciting. It's less exciting naturally when you go onto the web. If you find some data, most people are more excited to find a poem or a picture or a movie. But there are a number of reasons why actually data can be more exciting, can be more important for society. If you're browsing around the web, you're browsing an article in some foreign magazine, and there is an impassioned plea for a particular political attitude, and there is a graph which shows how this is changing faster than this. And when, hopefully you have a good skepticism, maybe you're learning from your children how to be skeptical when you go out onto the web, and so that the hair on the back of your neck bristles, and you think, well, wait a moment. Is that really increasing faster than that? What makes you think so? So at that point, sometimes you're frustrated because you can see this guy's produced the graph, but how did he do that? What data did he use? So in the future, what you should be able to do is that you notice at the bottom of the graph there's a link back to the data. And if you're an academic, you should be doing this. You publish a chart on the web in a paper, you should put a link back to the data so that other people could generate the same chart. But they'll do more things as well. When you pull in, you say, I can get the data. Let me pull in the data. I want to see what data he was using. Oh, that's interesting. Let me compare that with the data that other people have been using. Wouldn't it be interesting when in the States where these political parties are so incredibly polarized, they put up things which seem to be in complete contradiction. Wouldn't it be nice if we just drill down and see, what does this effect have? What is the effect that increasing taxes typically has on business, for example? So drilling down into the paper, in a way, is very important, I think, for the press. I think it's very important for freedom of information. I think it's important for science. It's also, so I've been encouraging people to put data out there on the web. And of course, there's lots of different types of data. There's scientific data, which is really important for if we're going to be able to solve some of these huge challenges like understanding Alzheimer's, understanding cancer, understanding how the brain works, that's masses of data. So scientists need to move more and more towards sharing their data with each other more openly on the web. And that's something which is happening. If you look at Science Commons, for example, there's lots of data we need about the state of the world ecologically. We need to understand global warming. And for that, we need to share a lot of data between countries and between academic fields as well. So I've also been pushing for open data. Let me tell you a little about the particular technology, though, of linked data. Linked data is technology which uses, there's a model called RDF, there are standards, you can look them up. There's a standard language which is very nice to write data in called Turtle. There is a query language called Sparkle, which is a little bit like SQL if you've programmed a database, but it's a protocol that runs over the web. There are various other languages that are standardized, which allow you to share data. But it's linked data, and I want to just talk about the value of linking data. When you do pull in, if you pull in a spreadsheet, somebody else's spreadsheet, then it will have columns, and it may have columns like city name, population, age of founding, country, or something. When you look at those, you may think, oh, yes, I understand what that is, but the column which is labeled pop, is that really population? When your computer loads that data, there's nothing that tells the computer that this column is population. So because the computer doesn't understand. It just displays all these tables. And you have to think about what they mean. In a world of linked data, actually, you can add information, you can add metadata. You can put data in and you say, oh, this column where it says pop is the same as when he says population. So when you look at some of the large linked data databases, there's one called DBpedia. DBpedia is the data taken out of Wikipedia, arranged into a linked data database. So you will find there a URI for population. With linked data, when you identify terms like a column, use a URI, one of these HTTP things, and that allows you to say, this concept of population is the same as that concept. And now the computer can help you. So when you do a query, you say, okay, I want to show me the countries which have populations greater than this, and also or have populations smaller than this, but have bars that play jazz music or something. Then you want to then you look at your own data and not find any, but because the data has been linked, when you pull in data from other data sets, then the machine will be able to find you answers. That sort of power of being able to link the data sets together. Also, when you talk about a country, you talk about data about Oman. Well, just having it labeled Oman isn't very good. We need to be better now. We need to actually mean, yes, you mean the country, Oman. And you mean, when we say Oman in this data set, this row means exactly the same thing as this data set. Or if it doesn't mean the same thing, this is how they interrelate. So linked data standards are available. They're w3.org, and the great thing about them is that they allow you to work with data which have been produced by different people who don't talk to each other. That's the real challenge. People are saying, what is big data? There's a lot of fuss about big data now. Well, big data is data which is more difficult to handle. And for me, big data, one of the things about big data is that it comes from different people. These people haven't talked to each other typically. This will happen within your government. As you produce these e-services, which we heard a lot about yesterday, you will find that different people, as they produce e-services, they will have different ideas about what population means. They will have different ways of encoding things. It allows you to take that data produced by different people who did not talk to each other, and after the fact, add connections which make that data really valuable. It allows you to pick your battles. It allows you to pick where you're going to spend your energy. It allows you to say, in Oman, in every university, we will have, every course in every university in the country, we will have the following 10 fields. We will know its title. We will know in a standard form which course, which term it runs in. We will know who teaches it. We will know, and so on. We will throughout Oman, we will have a classification of the different categories of course, because we want to be able to allow students to mix courses from different universities. Okay? And we'll decide to go to the trouble of standardizing that within Oman, but we won't try to make an international standard, because it's just too hard to make an international standard. We'll just save our energy, because it takes energy to make standards. So the great thing about linked data is you use a limited amount of energy and you get a certain big benefit. So you make standards where you have the energy to do it. Linked data is about picking your battles, deciding that you will standardize where you need interoperability. It's about sending data around. Therefore, if I send some data to you, some of that data will be written using vocabulary which I understand and you don't. And that's okay. The way the linked data world works is that your system will use the data which it understands and ignore the rest of the data. And you can achieve a huge amount. So that's a very simple philosophical change that linked data introduces. Before linked data, people would say to get everybody in the country working together, you have to get the government to make a big data schema in which every single piece of data is completely well defined. And actually, that's too difficult. So linked data allows you to be loose. Allows each department to have its own standards and for them to be connected loosely with the edges, like the pieces of a quilt. To make a flexible quilt, where within each patch on the quilt, there's a lot of standardization, but there's less standardization across the quilt as a whole. I talked to the CEO of America Online at one point, when America Online was a company which at that point was buying American Online. Time Warner was buying lots of media companies. Every few weeks, it seemed, they'd buy a new company. And then when they bought a new company, the CIO of the Chief Information Officer would tell the new company, you know what, there are 10, or actually it was 11 fields that we need to share across the entire group. So for everything that you own, if it's a record track, or it's a movie, or it's a poem, or any intellectual property you own, then I need to be able to see these 11 fields. For the rest of it, that can depend on the way you run your company, it can depend on what sort of asset it is, but just this, but these are the 11 things I want, and I'm going to spend my energy making sure that you give me those 11 things. So, these, if you understand one thing about this world of linked data, that it's a social thing as well as a technical thing, and in general, of course, you should remember that whenever you're developing anything, that in this web, that there's always a mixture of social and technical things. So I talked about two important directions in which the technology is going. I will touch on, before I wrap up, a few more general things. Yesterday, at the end of the talk, I pointed out that if you use the web, then also you have to spend some time doing, if you like, the care and feeding of the web, making sure that it's preserved, that its properties are preserved, its openness is preserved. The web was designed, as much as possible, to allow internationalization, to allow people to design a system which works for Latin text, going left to right, but also works for Arabic, going right to left. And also, which is more difficult, works for Chinese text going up and down. So it was designed to be independent of culture, independent of language. It's very important to keep that. When you design new technology, also, you should remember that the web has been designed as much as possible to be accessible to people with disabilities. Sometimes a website can be better than the old technology. It could be more accessible, because a book is a book, but a website, if you can't read, then it can give you an audio version. If you can't see very well, it can give you an audio version. Or if you're looking at it and you can't hear very well, then it can give you captions. So building in accessibility is something we're trying to do to the standards. We try to give you tools. If you develop new technology, then remember to make it accessible. I know that accessibility, I've heard from the yesterday when the prizes were given out, that if you didn't have, if your system didn't work for people with disabilities, then you didn't get a prize. So I think I'm glad that a lot of people around to recognise the importance of that. Designing for accessibility to a certain extent involves universal design. It means designing at the abstract level, rather than just thinking about what the user interface is going to look like. And that universal design is good anyway. So as you design, make sure that you keep it an end-to-end system. If you're building a fancy, new, powerful internet in Oman, make sure it ships the bits from here, from the edge of the network to the other edge of the network. Just ships the bits. The old idea of the telephone networks before the web was this telephone exchange should add lots of things. You should have inside the network, you should have the answering machine, you should have all kinds of added value. But the internet model is no, the added value is at the edge of the web. The job of the internet is to be just a transparent cloud. I put the data in there, and just like it's been for 40 years, drop a packet in here and it comes out there. That's the magic. The end-to-end system, not the decentralization. Remember that it's layered. Remember that it was 1969 that they developed the internet. And 20 years after that, I could come and develop the web. Now, more than 20 years after that, you can design things on top of the web. Keep it layered. Maybe you'll design a new layer. When you do technology, build it as a layer. Build it so that you're not assuming how it will be used. Build it so that it can be used in many, many different ways. So, if you like, design it for the people who are to come in the future and who are going to build things which you can't yet imagine. That is some of the care and feeding of the web when it comes to technical. That's how to keeping those things in mind is important when you do develop new things. But also, of course, one of the things which we're doing a lot recently is not only thinking about how you can make the stack but more and more powerful. As we do, every time we do new technology, we make the whole web more powerful, more exciting. And every time we do that, we make the gap between the person who's got web access and the person who's not got web access bigger. So also it's important to think about that gap. I know a lot of people in this country, a lot of the questions I've had have been about the digital divide. How do we get internet to people? How do we get people who speak a very obscure language, who don't know Arabic or English or Chinese, any of the very widely spoken ones? What about people who speak dialects, which are very rare? How do we get them to get a critical mass of information on the internet? If you look at one of the places you can go to look at a view of some 61 countries, comparing them in various different ways, is thewebindex.org. If you Google for the web index, then the World Wide Web Foundation has put out a list of 61 countries. Oman is not in that list. It would be great if we could get the data next year to put Oman in that list. And you can see there comparisons built up from lots and lots of different pieces of data about which compare which countries in the world are doing well or worse when it comes to making the best use of the web, making sure that it has the best impact on the best social impact. So that's one way in which, when you look at the things that have been put into the web index, that's one of the ways I'm looking at what sorts of things should we be doing in Oman. It's been great while I've been here. Lots of people have asked questions about what the country should be doing. I think certainly the initiatives that have been to put Arabic content on the web are great. I think that building One is it's important to be part of building a World Wide Web, of which a lot of it will be in the well-spoken languages like Arabic and so on. Yes, it's also important to put content out there about what you yourself are interested in maybe in a dialect that you speak and other people don't speak. So while we're making the World Wide Web, while it makes the world a global place, maybe while it makes it a more peaceful place, also it's important that you should use the web technology to make the web, make the world also, keep it a diverse and exciting and varied place as well. Thanks very much.